rather than showing just the picture. All right, we're directed to find the magnitude. It'll come up when I start writing. We are directed to find the magnitude and directional angle of the resultant. Remember, resultant is what happens when I add my x values together and what happens when I add my y values together. So if my two things are, how much work did I actually do? So yeah. So let's do our resultant first. Our resultant would be our x values added, so that's 2 plus 3, comma, negative 6, plus 5. Well, that resultant is just going to be 5, comma, negative 1. And now all the question is asking you to do is find the magnitude and direction and angle of 5, negative 1. Well, I always said do your magnitude first, get that out of the way, because it should be the easiest. Either you know how to do it or you don't. And our magnitude is just going to be, I usually just set a v for it. You can put whatever you want for it. Is going to equal the square root of 5 squared plus negative 1 squared, which is going to equal 5 squared is 25, 1 squared is 1, so it's going to be the square root of 26. That is my magnitude. Now we're going to do directional angle. Whenever I hear directional angle, I'm going to plot where this point is at 5, negative 1, so I can see what it should be about. So we do an xy coordinate. I plot the point 5, negative 1, which might be here, which would be over 5, down negative 1, which creates that triangle. Well, the theta I'm actually looking for is this big circle here. That is the theta I'm looking for. So just by drawing it, I know it's somewhere between 270 and 360. Because I'm looking for how far did this arc go. Well, that already limits it to two possibilities. It's either B or D just by plotting this line. In order to find this theta, we're going to use this alpha that's right here because it creates a triangle. So we're going to call that my alpha right inside of here. And note that alpha, we can use tangent of alpha equals opposite over adjacent, which is negative 1 over 5. Once again, it's just y over x. If you don't draw the picture, it's y over x as long as you know what quadrant you're in. Which is going to give me theta equals tan inverse of negative 1 over 5, which was about negative 11.3. But that negative 11.3, none of these are going to be negative. All right, none of these will be negative. That negative just says either do 180 minus 11.3 or do 360 minus 11.3. Well, I know it's all the way in quadrant 4, so it's got to be bigger than 270. So in fact, we're going to do 360 minus that little bit. 360 minus that 11. That will give me my correct answer. So theta is actually equal to 360 minus 11.3, which you should have gotten out as, what did I put as B? Is your 348.7 degrees. All right, any questions on how to do that? We've done magnitude and directional angle on almost every one of our bell works because it's going to be on the test. It is. And if you can do this one with magnitude and directional angle, you can do the easier one where I just go ahead and give you a vector right off the bat. Just know these steps. Magnitude, x squared plus y squared, take the square root. Whenever I say directional angle, draw it. Figure out where it is between, right? I knew this was between 270 and 360, so when I got negative 11.3 out, I knew it had to be 360 minus 11.3. Questions, comments, concerns? Kind of a good thing to think about is if your vector is in quadrant 1, your alpha is going to be the same thing as your theta. If you're in quadrant 2, it's going to be 180 minus your alpha. If you're in quadrant 3, it's going to be 180 plus your alpha. And if you're in quadrant 4, it's 360 minus your alpha. All right, it's good things to think about while you're plotting this. All right, what questions do we have on the homework? Yeah, Teresa.
Alright, so first do I have the same question for when you did, you used the law of sines to find angle A and angle B?
Mm-hmm.
Or, yeah. You used a different side than I did to find them.
I used a different
You're
side.
supposed to use the side opposite of, aren't you?
Let me look what I did. Let me take a picture of it and we can walk through it. So on the first one, you didn't even have to use the law of sines. You could have used the fact that it was a right angle, but I refused to do that just in the fact that that is such a rare case that I did use the law of sines. So here's my answer. So I'm assuming you got that 8.5 pounds because you didn't have a question about that. All right, so I'm checking this one first. It depended on which one you might have. Did you put your 3 pounds or 8 pounds down here?
Oh, my 8 pounds.
Okay, you put your 8 pounds down there. That's why you would have been using something different. Yep.
Okay.
It was just where I started. Yeah.
Okay.
Yep.
So they're going to be switched.
Yep. Everything's gonna be switched. It's just which one you put here and here. Is that
Yeah.
make sense then? Yeah. Okay. Good, Catherine.
For the second one, why did you put the 23, like?
Oh, on the next problem, right?
Yeah.
I was just like. All right. Why did I do what?
Put the 23, like, on the left vector. Like, why wouldn't the 34 go there since it's the taller one?
Oh, you could put them on either side.
Okay.
And in fact, if I was doing this correctly, I would have. The 34 should have been longer, right?
Yeah.
Should have been a little bit longer. But this is just, it's just a rough draft to help us figure out what to do. But there is no right, you don't have to put the long one on the left-hand side. You don't have to put the long one on the bottom side. In fact, if you look at all of them, every time they mention the first number they mention, I put on the bottom.
Okay.
Because I basically did my drawing, and then whatever my first one was, I put on the bottom, and whatever the other one was, I put on the side. So no real rhyme or reason, doesn't matter where you put them.
Okay.
Good question, though. Those are the kind of questions I like. Where you knew the answer, you just wanted to know why I did what I did. Other questions from the homework? All right, if there's no other questions,